Dear students, today we'll see what do we mean by scanning, and in scanning we will see what do we mean by progressive scanning, and then when we are adopting progressive scanning we will face the problem of flicker, and to eliminate this problem of flicker we have to go for interlaced scanning. So what is this scanning process first? What is the flicker problem? And then what is interlaced scanning for TV transmission? So here, today's topic will be progressive scanning, flicker problem, and interlaced scanning. So here, to start with, according to CCIRB, that is a consultative committee for international radio standard, which is adopted in our country. According to this specification, it says that there are 625 lines in one frame. Okay. So here, if you see one frame means one picture. If you take one picture, so this is in the ratio of 4 is to 3 or 16 is to 9, anything you can take. So here you can see that it is having horizontal scanning lines which will start from left to right, left to right, left to right. So like this you have around 625 lines. Okay. Now this is one picture, one raster. Okay. Now here, while you're doing this, we should also mention what is scanning. Okay. So when you scan a horizontal line from left to right, okay, this is the end of the line. This will be called as trace. Trace. Okay, so the electron beam is scanning the line from left to right. All the picture information is taken, and this is your main picture information what you're going to give. So first line is scanned and you are coming to the right of the first line, that is the end of the first line. Then to go to the next line you will be having a blank period, and then the next line will start its trace. So here you can see the trace for the next line. Okay, so this is line number one, this is line number two. Okay. Now this what you are coming from the end of the first line to the start of the next line is called as retrace. Retrace. Now retrace will have no information, and in that period the picture will be blanked for some fraction of seconds. Okay. So tracing of the first line, then retrace, then tracing of the second line, then retrace. Like this your horizontal scanning will go. Once all the 625 lines are completed, that means from top till bottom here, if all the 625 lines are completed, then we go to the next picture where again first line, second line, third line, fourth line till 625 lines will be scanned. Now this coming from top till the bottom of the last line is called as vertical trace, and coming to the next starting of the next picture first line is called as vertical retrace. So like this we can go scanning picture wise picture. This is the first picture, and this will be your second picture, then third picture, fourth picture. All that will be continuously scanned so that for a motion film, for a video in motion, you can see that the motion is taking place. Okay. Now here, coming back to the topic, according to CCIRB, there are 625 lines in one picture. Okay. Now, if you go to see, there are two types of scanning. One is called as progressive scanning, and because we have a problem arising in progressive scanning, that is flicker, we go to interlaced scanning. Okay. Now, in our progressive scanning, it is simple. All the 625 lines in the frame are scanned in progressive order from top to bottom. Okay, so all the 625 lines are scanned. Say this is a picture. Okay, so this is your raster of the picture or the frame of the picture. Okay, so here you're going to scan from the top left hand side first line end, then you have retrace, again scan, again end, again you have retrace, again scan. Okay, so like this, if you scan the complete 625 lines in a progressive order from top to bottom for every picture, then it is called as progressive scanning. Okay. Now, if we do this progressive scanning, then we will get a rate where there are 25 pictures or frames per second. 25 pictures will be transmitted per second if you take the horizontal scanning and then vertical scanning from one film to another, that is one picture to another. So you can send around 25 pictures per second. Now, this or 25 picture per second frequency does not match with our line frequency of the power. Our line frequency of the power is 50 hertz. Okay, so this or 25 pictures per second will create a problem called as flicker. Okay, so here, if you see the progressive scanning, 1 to 10 lines are shown. Like this, 625 lines we'll be having. And then when 625 lines are finished, we go to the next picture. Then again, 625 lines are scanned. Then we go to the next picture. Then again, 625 lines are scanned. But like this, if you send pictures per second, then you're sending 25 pictures per second. So here you can see what is the trace and retrace lines. Okay. So now here, coming back to our statement, there would be only 25 blankouts per second, that is 25 pictures per second, which result in a flicker problem. Now, what is this flicker problem? Now, if our 25 picture frames are shown per second, then brightness of one frame will not blend smoothly into the next. The screen appears alternately bright and dark, resulting in flicker. Flicker effect can be reduced by increasing the blanking rate, and to achieve this, interlaced scanning is used. Okay. So this is what is flicker is. It is a problem when the brightness of one picture, one frame, will not be transferred to the next frame smoothly. You will notice with your eyes that something is going round. Some black and white strips are coming in your picture, and that can be noticeable if you are sending 25 pictures per frame. Okay. But this number or 25, if you convert it into 50 by some means, then you can eliminate the problem of flicker. Okay. So here you can see the problem of flicker we have shown. So here you can see this black spots lines. These are black lines. Then again bright, then again black, again bright, again black, again bright, again black, again bright. So this is what happens when you are having a flicker in the picture. Now here, what we will do is we will go for something called as interlaced scanning, in which what we will do, the 600 or 25 lines, whatever we have per picture, 6 to 25 lines, 625 lines, we will divide them into two parts, that is 312.51 part and 312.5 another part. One will be called as odd filled and one will be called as even filled. Okay, and when we send this fields per second, then for 25 picture you will be sending around 50 fields. Then you will be having a frequency of 50 fields per second, and this will match with the line frequency of the power, that is the 50 hertz, and thereby that noticing that black and white strips, noticing that the brightness is not been transferred from one picture to another picture properly, notice of that will be eliminated and this flicker problem will be eliminated. So here you can see the first field we will be having 1, 2, 3, 4, 5 lines. Second field will be having 6, 7, 8, 9, 10 lines. Say for example, then here the second line will be the first line of the second field. The third line will be the second line of the first field. and fourth line will be the second line of the second field. So like that alternately we are going to send the first field and the second field, that is the odd field and the even field. That is what happens in interlaced scanning. So here in this case we say that it is around 50 fields, 50 fields per second what frequency we get, and because of this the problem of flicker is solved. Okay, here we have also shown the progressive scanning for 10 lines. So for 10 lines, if you want to speak about progressive scanning, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all will be in order. But if you want to make it in odd field and even field, then 5 lines will go for one field and another 5 lines will go for another field. And alternatingly, we are going to send it in our interlaced scanning here. Okay. So in our progressive scanning, we will face the problem of flicker because the frequency rate is not matching with 50 hertz. And in interlaced scanning, because we make every picture into two fields, odd field and even field, then it will be 50 fields per second, and this 50 will match with the line frequency. Thank you, students. So this is what was your progressive scanning. And then in the progressive scanning, we had a problem of flicker. And to eliminate that, we went to interlaced scanning, where each picture was divided into two fields, odd field and even field. And then we had 50 fields per second. Then that if you transmit, we will eliminate the problem of flicker. Okay. Thank you, students.